Welcome to part 2 of 6.1 notes, where we're going to start getting into the main focus of this chapter, which are initial value problems. And actually in this section, we're also going to look at slope fields because the AP test tends to put these two concepts together in the same problem. The first thing we're going to look at is how to solve an initial value problem. And then in the second video, we're going to look at what slope fields are. And then in the third video, we're going to put the two together. So basically, we talked about this at the beginning of part 1. An initial value problem is when you need to first find an antiderivative, and then you need to plug in the initial value, which is this thing right here, to figure out the specific solution for y, because we're basically solving for y. So we're given a derivative. We're given the derivative of y, and we're asked to go backwards basically and find the antiderivative, which is y, but not just any antiderivative, the one that would satisfy this initial condition. So that's why it's called initial value problem, because this right here is called the initial value or the initial condition. So you want to follow these steps, and you want to follow them carefully, because if you follow them carefully, you can get tons of partial credit on the AP test. So step 1 is you want to separate the variables. And I cannot stress to you how important this step is. Basically, it goes like this. If you do this step in the AP test, you get partial credit for this step as well as all the others. If you don't do this step, you have no opportunity of getting partial credit later on. So it all comes down to if you remember to separate the variables first. So what I mean by that is, right now we have dy dx as a derivative term, but I want to think of them more as differentials, what we talked about in chapter 4, differentials. So I want to split it up so that I've got dy on one side, and any terms with y in them would go on the same side as dy. And then any terms with x go on the other side with dx. So I have cosine x plus sine x dx. So that's step 1, is separate the variables. And then step 2 is you want to basically integrate both sides. And so that involves finding antiderivatives. And so we can use the formulas we got at the first part of these notes, or we could just kind of think backwards like we did in chapter 5 and figure out what function would give me this derivative. Okay, so I'm going to go ahead and integrate both sides. And I'm going to just go ahead and throw down the number 1 right here, because even though it's there, sometimes we forget it's there. And I'm throwing that down because I need to basically find the antiderivative of the number 1 with respect to y. And so that would basically just be y. And if you're not sure, you can check. The derivative of y is 1. And then notice once you take the antiderivative, the dy goes away. Okay, then I need to find the antiderivative of cosine, which would have to be sine. And again, if I'm not sure, I can check. And the derivative of sine is cosine. So I'm good. And then the antiderivative of sine is negative cosine. And again, if you're not sure, you can check. The derivative of negative cosine would be negative 1 times negative sine, which would turn into positive sine. And then you don't want to forget to add c. Got to add that constant. It's really, really important. And actually, this constant is a combined constant, because I really should have also added a constant over here as well, because anytime you do an integral, you should add a constant. But if I had a constant here and a constant here, I could just like subtract or add this one over, and then this one would just become some other constant. So we just think of it as a combined constant, and it's good enough. Okay, then step 3. Is you want to plug in the initial value. Because right here, this is a collection of all the possible answers for y, depending on the value of c. Or I could actually find the value of c and get the exact answer for y. And the way I find the value for c is by plugging in this initial value. And I want you to notice that when you see something written like this, what that means is that x is pi and y is 1. And so it's basically an ordered pair, just given to you in a different form. So I'm going to plug pi wherever there's an x and 1 wherever there's a y. And so I'm going to get 1 is equal to sine pi minus cosine pi plus c. Well, sine of pi is 0. Cosine of pi is -1. So I get 1 equals 0 plus 1 plus a constant. And then to get c by itself, I'm going to subtract this 1 to the other side. And I basically find out that the constant is 0. Excuse me. So then I basically just write my solution or solve for y or whatever. So I guess step 4 would be solve for y. So y is basically equal to sine x minus cosine x plus 0. So I don't really need to do any more work. And then I'm going to sneak in a little step 5. Sometimes you have to do this, sometimes you don't. Depends on what the AP test is asking for. So this is really just for the AP test. If they're asking for it, you'd want to state the domain. You want to state for which values y is equal to this. And so we kind of go back and look at the original. And they didn't give us any restrictions here because cosine x plus sine x is equal to, is defined for all real numbers x. There's no corners or cusps or anything like that, and there's no points of discontinuity or anything like that. So it's smooth and continuous everywhere. And so I can basically take the antiderivative here, which would be smooth and continuous and defined everywhere. So the domain here would be all real numbers for this particular example. Okay, so the next video, we're going to go ahead and take a look at slope fields.